and we talk about deep learning. So I just mentioned about retina, and then I want to compare with the YOLO V4. So for the YOLO V4, now YOLO V4 is very good. I did not say no, it's very good. Okay, so they have a dark CPS, and that's upsample and feature pyramid network. One more downsample. So this is PNet. This one is PNet, and then output. So this is a good one. But what I say is that sometimes it's not easy to modify. If I only have this one and this one without this PNet, without this one path aggregation net, without this one, this will become the retina. But difference is this is YOLO V4 has good one. This is the 那个廖老师他们弄的，这个有那个 darknet is really good. They are doing really good. 那this one RetinaNet. RetinaNet. This is use ResNet. So if you compare with RetinaNet and YOLO V4, YOLO V4, the one thing is that RetinaNet, but RetinaNet is earlier. They use ResNet. Okay. And YOLO V4 is good. Is that they use the darknet or CPSNet because they are more like the way. I mean, the parameters they reduce a lot of parameters. But YOLO V4 has one more downsample. That's PNet. So what I mean is that if you just use it, I encourage you to use YOLO V4. But if you want to modify, sometimes YOLO V4 is not easy to modify. So sometimes we use RetinaNet. It's easy to modify. Modify, what I mean is modify here. The second one you can modify is here, the head. So if you want to modify only the head, okay, and the YOLO V4 is also can do that. You can directly modify YOLO V4 or RetinaNet because it's output head, the output head on both. You can, I mean, they are, how can I say, they are compatible. 它们可以就是可以比较相容的。你就只要前面不一样嘛。那你要 modify 后面的话 ，head 方面的话，那 YOLO V4 当然是可以，你可以去改它的东西。那 Retina 这边也可以改它的东西，这样子。所以 head 这一块，就 head 这一块，这两个到底要用哪一个？到底用哪一个？我现在没有，这两个都还都可以去改它。你要 head， 只是说 YOLO V4 已经很笨重了，你 head 越改，只是增加它的那个负担量这样子。OK， 但是这两个没有，就是都可以用。那我们继续哦。所以 this one previously we used this one for AOI defect detection inspection， 这我之前做的用 Retina 来做，之前有做。因为那时候还没有YOLO V4。The other one is very famous. We call UNet. UNet is very famous. So UNet is. So what I always say, this UNet and this RetinaNet, very similar. One is this way, and the other is this way. 这是标新立异而已啊，这两个是是一样东西，但是它当然架构不一样。这是shortcut，所以这两个都比 YOLO V4 还早，这是画法不一样，当然架构也不一样。我说大致来讲，这个画成这样子，是从这个 down sample up sample， 这个只是相反，是 down sample up sample。OK， 所以 RetinaNet 跟 UNet very similar。 I talk about because actually UNet is very powerful. 那我昨天去 Intel，他们也跟我讲，我们有用 UNet，我们有支援 UNet，是非常好。好，大概讲一下，大概讲。So this one is simple, easy to understand. Okay? You do two convolution and downsampling, two convolution downsampling, two convolution downsampling. But here, you do upsampling, but you concatenate. So the upsampling, your channel will be 512. You concatenate 512, so total channel will be 1024. And you reduce the channel, like upsampling. So upsampling, you originally you have 1024, but you do your channel number reduce 512 and reduce one more, become 256. So this channel number will be the same as this channel and do upsampling. So this channel, I say originally is 1024, but you change it, you reduce the channel number 1 time, 2 times, and then become 256, and concatenate again, and reduce 2 times and concatenate, and up to here. And final one, you'll find out. See, this is 64 by 64. You come here, concatenate 64 by 64. That's okay. But final output, your purpose, this purpose try to do segmentation. UNet, the purpose they try to do the segmentation. So that's meaning for each pixel, you will classify foreground or background. So it's 2 classes. The output for UNet is for each pixel. You classify to be either foreground, that's 1, or background 0. So it's 2 classes. 你的输出就是前景跟背景对每个 pixel 来讲，所以是2个 class 嘛。class 1就是前景 ，class 2就是背景，所以是 2 class， 那就输出。So the good thing is UNet here, it looks simple. Actually, it's much simpler than the RetinaNet. RetinaNet 比较复杂一点，就是 ResNet 就 very deep, right? ResNet is very deep, and UNet is just this kind of convolution. 所以这个比较没那么 deep， 这个比较 deep， 那是 upsampling， 有另外一个 upsampling， 所以这2个不一定对称。那 UNet 是对称。好，那再来，我已经上有点忘记了，就 the older UNet 我已经有点忘记架构，但是新的 UNet 有人改成什么？这很单纯，改成什么 ？convolution， 那个 batch nomination， 然后那个原路就这样，就是每一层，老师上课有讲，就说我们目前大概有这个例子，这个每一层每一个层是用这个写，这个每一层，那现在新的。我忘记旧的了哈，但是我说新的话，这里很多人都用这个，就是 plus plus。So when I say why UNet is I like UNet because not only me, many people like UNet because it's simple. And right now, people change it for each one, change it just easy. Convolution, patient organization, become one set， 就这样很单纯，就在这里连下来。那每一个大层就是这样做。啊 ，upsell 可能用 liquid 这样子，这很单纯。我说为什么 simple is easy to modify 这个意思，很容易就可以改，结果就又提升。So this is for encoder, this is for decoder。结果非常好，结果真的很好。这是 Unet， 你可以试试看。我昨天晚上稍微改一下，就是之前帮助那个不是帮助了，跟就水利，就我们工学大道的最深刻的对面那一栋水利什么系那边，帮他做了油，这台湾的油外海油，做的非常好学生很厉害。那做完这个油污以后，就跑去台积电，所以我们训练很多学生都被台积电收走。这不是我的学生，这是我们跟水利系的合作，我很高兴啊，就帮忙指导了，就共同指导。那指导完，那做的，就是这个油污，那这 ground truth 做出来，这不容易，有些不容易，看这油看不大出来，做出来，做了，用 Unet 来做。好，做完，学生很高兴，又去台积电。啊，老师不一定很高兴，老师很高兴学生去找到好工作，但是台湾又失去一个人才，在这个环保上面，就这样子。OK， 好，好，再来 multiple input。So right now we talk about here。我们讲这个，再讲这里，然后慢这里。Okay, so this example is we do the robot arm. So we try to pick up this thing. So we have input is RGB image. Right now we have depth image because right now like a real sense, there are more camera has more. I mean right now from 2D camera and right now we have a more 3D camera, so we have more depth information. So the input become RGB and D. Way to separate. Why not RGB plus D input together? The first one is the first reason is because right now most networkers input 3 channel only, 3 channels only, right? Only 3 channel. The second is that the RGB information is different from the depth information. This information are different, so we separate. So this is RGB, and this will be DDD. Sometimes only 1 channel, sometimes 3. The depth input here. So the input to the VGG16, and after here, and we do concatenate, and then input to the RPN. So this is the first RCN. Basically, this is first RCN. The difference is the original first RCN and only RGB, but right now we have a depth. Okay, so here we do the initial bounding box R1, and we do the normal alignment and become feature. So each, because this is do the normalization to be the same size. So each bounding box we have a features. So these features, and the blue one is from RGB information. The depth we keep here. So here important thing is that we until here for the channel we still separate the RGB and the depth. We did not really mix together. And final output we will do the classification, and then this is the bounding box. And we also apply this result to our robot arm. So this we try to pick up. There's a piles of object 一堆东西嘛，然后一个个把它抓完了，这种学生做的。我有一个学生，电机系的，就是我们成大电机系的学生，我的几年前，7年前，6、7年前，他现在在那个也是台积电的台积电有做 robot arm，他的 robot arm 是在改造旧厂，他说旧是那个第3厂或者什么，台积电新厂，台积电新厂并不代表那么新，它很多自动化是改旧厂，不是改新厂，你新厂就直接做自动化。台积电的自动化全部在做旧厂，因为新厂都买最新设备，他在旧厂把旧厂的整个厂变成自动化厂，所以他们电机系的，他有时候回来一个女生，不记得名字，太多学生，他去台积电那个自动化部门，啊，那他改的是做这种 robot 东西。对，我在讲这里。那 we will try to pick up this thing. So the input and output will be see the bounding box. And based on the depth information, we can judge and decide the top one. So the top one is based on the depth information. So we can pick out the top one and then try to find the normal direction. For each domain, we try to find normal direction. Use PCA SVD. Use eigenvector. Try to find a normal direction, and they can pick it up. So we try for each cube, we try to find the normal direction of the cube, the surface. So robot will along the normal direction and pick it up. And the way we try to find a normal direction, we use the PCA. So that's an eigenvalue 1, 2, 3这种方式来做。好，看一下我们做的结果。这是 real sense。这是看到的 death， 这实际的摄影机，实际场景，所以 pick up find this one and try to pick it up。Each time he pick it up and then they take a photo again， pick up， 他自己决定要抓哪一个，抓着，就让他孤单单在那边做这种无聊的动作，做了。好，那做这个要做什么？就没什么用，无聊。那是公司需要的，但是做这个抓螺丝，他就找最上面那一根螺丝，去把它抓起来，抓螺丝的动作，他决定哪一根螺丝，这个抓起来，这之前做的。好，那再继续讲。The other application is previously we talked about this one. We call this is based on we modify the Fester RCN for this one. This Fester RCN. Here we call Siamese. One network we call Siamese. 双胞胎的 Siamese 的。So the application this way. Suppose I take one photo. So you'll find out the foreground is clear, the background is blurred, but the second image is foreground is blurred, background is clear, and we merge both together. Actually, that's meaning we will try to let the network to pick up a clear pixel and put here. So we fuse both image to be one clear image. So no matter its foreground, background, all are clear. We use this one. So the same this one. We take this one, take this one, and we fuse this one to the result. But in the other word to say, if we pick up this one, right, can we try to do the discount photo and discount photo? Yeah, this we can do that. Use a network. This is if we fuse both to be one clear image, but can we reverse from one image and we create the blur, some pixel blur? Yeah, we can do that. Okay, so back to here. So how can we do that? Do this one. So for each page, not in image, for each page. So each page we input here, and this can be VGG16. Don't be too complicated. So we can do VGG16, and then output become feature maps, and we concatenate the feature map, and output to be clear image. So this is simple. I always say, not anything is just a complicated network. Sometimes we still need a simple network like VGG, like ResNet. So this is easy. We use VGG. Many people in Siamese, they use to input, they use the VGG16. And they concatenate and output what you need. So we can do this one. We call Siamese. Okay. And next one is tracking. In tracking is a big field. Siamese is also a big field. I just use some example. So how can we track it? So suppose we have template here, and next frame here. And how can we do tracking? An easy way is suppose we do template matching here. So original, we input this one to template matching here. Input this one. So this is template. This is search region. And we input here. So this result, suppose this result will do the scan line to search. 就是说，我们要想为什么要用那个 network？ 为什么？那我们一开始有讲，我们不管做 encoder 啊，做 detection tracking 的东西，那我们是要可以把原始的 data 输进去，直接做这些东西。以前 computer vision 是这样做。那为什么现在需要 deep learning？ 因为 we want to extract more information, more useful information here. Okay, so suppose the template is this one, 127 by 127 RGB3 channel. This is your search region. Okay, so we do extraction, feature extraction. For example, we use VGG16, and we have an output here. Downsampling and more feature. So here we have more features, 6 by 6 by 6 by 6 by 12 and 128 channels. This is 22, 22 to 128 channels. So we do downsampling, we extract the features. So here we do template matching based on this one and this result. And we got a result here. So it's simple. So in the beginning of the tracking using in deep learning， 就一开始我们在做 deep learning tracking， 你会发现一开始的 paper，deep learning 的很多 paper 一开始都不怎么样，你现在看起来都不怎么样，这是比较早期的 paper。为什么不怎么样？因为它这里还是做就是 这个 window 啊，这个社区，只是它这里的 feature 变多了，变128个 channel，一般就是 RGB 3个 channel，RGB 3个 channel，跟你经过一 train 完以后，这里变成128个 channel，所以它资讯更丰富，面积更小，它在这里做 matching 完以后就把位置就总共17×17个位置把位置找到了。他用这种不算 tracking 啊，他用这种 matching 就是 convolution 的方式去把位置找到。所以一开始的 tracking 是用笨的方式来做，那慢慢就真的开始有 tracking 了这样子。我是让你知道说，deep learning 还在发展中间，那很多东西都是从 region 慢慢移过来。那我们之前跟你讲，我们在做 fast RCN。The initial fast RCN, they do select search to try to find the initial region of object. Now, selective search is kind of a computer vision method， 都一样。好，那我们后面继续。So this is a fast RCN, mask RCN. We have UNet here, right? We have mask, but mask right now we can use UNet instead of mask. First, we can use Retina, and right now it's YOLO. And we talk about right now. We talk about RNN and LSTM here. It's temporal domain， 跟时间有关的。我们之前讲的都是单张 image， 那现在讲是 with some relationship with the temporal. Okay, so one way is a RNN. R is a recurrent and this is RCN different. This region convolution neural network, and this is recurrent RNN or LSTM. Okay, so this is for temporal domain. And this one example. How can we do this one? This one example. And the major things that I want to talk about LSTM. So how can we apply LSTM to temporal domain? So suppose we have a time, 时间啊 have a 60 seconds， 这是60秒，60秒这样子。And our signal for each second we have 24 signals， 所以你24个 signal 进来。Signal is 1D, image is 2D, so this is 1D. But we have 24 signals, or one signal is also fine. But suppose we total have actually we total has 200 times, but each time we separate only 60 seconds. So this become HW， 就变成2D， 这时间轴，这是输的讯号轴。So before we use LSTM, the same, we still need to do encoder. The same. Okay, so this is encoder. Before we input to LSTM, we do encoder here. So here we see this one. This is the same as this one. So for training data, if our training data is not enough, we have augmentation 就把它增加。增加什么？就加上动语词啊，加上这些东西就增加。And then before we input, we do normalization because they are signal. Signal is that we have a maxima, minima, peak. So we do normalization. That it becomes between this one. We do the average divided by standard deviation. So this becomes normalization. That in between -1 and 1. But not really 就是让它压缩到一个标准的单位。So because the signal, remember, the signal is you don't know what's the range of signal. So we do normalization here. No matter it's training data or test data, we still need to do normalization. So we just use Gaussian model. So mass standard deviation divided by mass average value and divided by standard deviation. So this becomes normalization signal. And then we input to this one, and this is easy. Just feature extraction. Feature extraction of signal or feature extraction of speech recognition. Speech recognition, they use RNN, they use LSTM. So you can think about, we do this one in our case, we do is for the touring. 我们在做跟东台做那个东台经济做那个道具侦测道具的预测，那道具会震动，所以我们是透过它电流讯号、震动讯号，所以我们这里有24种讯号，加速规啊什么一大堆讯号，电流，有时候伏特嘛，有时候那个通常是电流为主的，然后一些讯号，这24种讯号把它丢进来，变成一个2D 的形状，但是还是1D 的。那一开始做萃取，萃取很单纯，看一下这里。So suppose you input is 24 signals and 60 samples 就是60的时间轴60秒。First of all, our kernel is 虽然是2D， 但是沿着时间轴了。So you see the output, you see the with is mean the time， 本来60秒，被压就当 sample 变成30秒，变成15秒，变成8秒，就变成1。这当 sample 30当 sample 1D 嘛，本来是60秒，当 sample 2除以2嘛，2是15，所以当 sample 是这样子。那再是 channel number，right？ So channel number become a signal。所以你本来24个序词，一个 vector， 那它这 case 就变18个句子，18个 channel， 36个 channel， 72，然后最后把 flatten。我再讲一遍，这是 signal， speech recognition。So the time is a time, so 60 seconds. So 60 seconds. What's the purpose here? 我们先看最后的目的是什么？目的是这个。目的做 prediction. I want to predict the second 61 second what happened. Okay. Input output. What's the purpose for this one? We try to predict. We call tool remaining useful life. That's meaning 它去侦测这把刀什么时候会断掉了，刀磨刀啊，刀子断掉，刀子的寿命。做 prediction， 所以它 predict 1秒，不是 predict 下2秒、下5秒，这是你自己可以决定的哦。You can predict 那个你的下面几秒会发生什么状况。那我只假设是 predict 1秒钟的话，那我讲它输入是60秒。那经过整个压缩，做这 LSTM 去 predict， 那上输出的话又是另外一个60秒，所以它上输出是下一个60，实际上是变成这个 signal 就变成综合成一个 signal， 那它去 predict 下一个60秒的状况，下一个60秒钟，那越近当然越准。那我们再回到这一边，就越61秒准、62秒准、63秒开始不准，越来越不准，但是它是 predict。So they will merge the 24 signal become 1 signal because they don't care about predict the life of the。它目标是 predict 这个寿命会不会断掉，断不断这样子，断的几率等于多少？下面60秒断的几率等于多少？那 probability for broken tool， 所以我再讲一遍，所以它很单纯。第一个就是 first of all I do down sampling， so using maximum probability， so I do convolution down sampling, convolution down sampling. Okay, so originally is a 60 second, so become 60, 15, 8, 1. But the the channel original 24 signals become 18， 这只是它设计的，就这样 written。So here is only one input, so the input to LSTM. Okay, and the output. This output they design it as the output. So after this output become, because they want to keep, here is 60 seconds, and the channel number, because this is 72, so channel number is the same, and finally become 1. So what's the LSTM? What's the LSTM? Right now, I try to tell you is that when you use LSTM, it's not input and then output. No. Before the input LSTM, you need to do the feature extraction. Before the output, you need to do some classification. Classify is broken or not broken. Classify the one you need. I say again, from the input LSTM for the temporal domain, you need to do feature extraction. From the output, it depends on what's your purpose. My purpose is try to predict the life of a tool. So whether it's dangerous, it's warning. Okay, so the output will become 0 and 1, between 0 and 1. So if close to 1, probably is safe. If close to the 0, that will be dangerous, will be warning. 介于0到1之间这样子。So this is about classification. Still need to do classification. So if you think about how can I, based on the classification purpose, and try to get the purpose what I need. 你要去想你输出嘛，你要把你输出的东西，因为它可能是一个分类器嘛，而分类器怎么变成我们需要的东西？那我刚刚讲的，像我们刚刚把2张有模糊有清晰影像，我们希望输出是一张很清晰的影像，那你就把它想成我的输出的值越靠近1就是越清晰，我越靠近0就是越不清晰，因为它也是一种 classification。那这个也是一样，我希望我输出的东西是目前是没有危险的，那就越靠近1，我越危险就越靠近0。那我要警告的话，可能是0.3到0.5就发出警告讯号。对，0.3到0.5发出警告，0.5以上我是 safe 不理它，0.3以下就是我可能换道了，一定要换道。所以这个定义是你要去想，我怎么去定义它这个东西，都用分类器来做定义。好，那我们来看 LSTM。那 for the LSTM because it's related to the time, so your input will be this， 因为你跟时间有关哦。那我们刚刚讲不是有60的时间第1秒到60秒 ，60 seconds. So your input here will has 60 input. So you will have 60 LSTM. 不是只有一个 LSTM， 这是一个 module。你输入有60个，因为你是输入60秒，所以这有60个，所以有60个输出。那所以这是讯号，刚刚讲讯号，第1秒、第2秒、第3秒是这样60个这样子。我们来看每个 LSTM。那 LSTM 是基本上就是这样子，以这个来看。So your input is a signal. There are 2 inputs. One is the current result. The other one is the previous time, the output of previous result of LSTM. 你 LSTM 你输入上方会2个，一个是你目前的讯号输入，第2个是你之前 LSTM 预测过的结果在输入，所以它输入有2个，通常输入会有2个，一个是你目前的状况，例如 for example, right now suppose you input the time 40, so you put a signal at the time 40 input, and this one will the output of 39 at the 39 second the result, the predict result will output to here，这样子，所以它跟时间有关，是这样子。那我讲这个你听不懂，我讲你在讲话的时候，我讲，我先用中文讲一遍。你在讲话 speech recognition， 你 OK Google， 然后你输入那个时间，you say OK Google，you want to speak a sentence, right? And then they want to your cell phone to automatically to type for you. So you will find out suppose totally have 10 words for one sentence. So you speak one word. So probably this has 100 input here. 你有100个，应该不知道你要讲多少。因为我不是 speech recognition 的人啊，我是举这个例，举这个我所了解的啊，不一定对。我假设这个输入100个，那实际上我很难讲，很少讲一个句子100个字啊，所以你一直讲，它会帮你分段。那你现在你会发现你输入的时候，你输入 one sentence， 那you have output here， 对， you speak one word， you output one word. When you speak the second word, you output second word. When you speak a third word, you output third word. However, they have information from previous one. So they output to here. So when you speak second word, we speak second word. This one will based on the current input and previous output. They will judge what's the word here. So if you speak longer, the correction rate will be higher. 因为你在讲的时候，你在讲话的时候，你不是越讲越长，它就会越正确嘛。But how can they correct here? 你不是讲完，它会修正你的词，这个没办法修正，这是出来就出来了。那有一种叫 two word， 就是那 two way， 这是 one way 这样过来。那通常 speech recognition 是 two way， 这里还有个 LSTM 进来，这 LSTM 会这样过来，这 LSTM 会这样，这每个会有拉回来，就会再过来。这里还有个 LSTM， 就是2层，这一层 LSTM 跟第2层 LSTM， 为什么会这样做？这样才办法去修正你输出的结果。你假设你做出的我不是 speech recognition 的人啊，但是我尽量用我所了解来解释给你听了哈。因为这个 LSTM 用 speech 会比较好解释。李宏毅老师是 speech 的，他很厉害啊。好，我讲一个字这样出来就出来了，讲一个出来就出来，没办法修正，那我怎么办？我去修正这个字，所以我只好在下面加一个 LSTM， 这个下面，但是我把这个箭头再拉回来，所以这里会有一个拉回来的 LSTM 在这里，这样子，这样我就可以修正我的东西。就这里还有第2排 LSTM， 这样的话，我先讲，我再讲一句话，一直讲了，这样讲过来，一直输入。那我们先讲 forward， 就是往前这 backward。那 forward 的话，我讲越多，它这个字会越来越正确。你自己用讲手机语音输入法是这样，但是它修正的时候就需要这里都需要回来，因为回来才办法继续修正这个字。你如果没有这个回来这条路的话，输出没办法修正。所以我们在做 speech 那个语音输入的话，一般来讲是 two way 的 LSTM， 它就有办法把这个输出又根据前面的资讯再把它修正回来，是这样子。好，所以简单来讲 ，LSTM 就是它收集你目前的资讯以外，它又把前面的资讯弄过来去做比较好的判断。就这里，它输入2个，所以这个输入它虽然是这样画， 但是基本上是两条路，这两条是一个是我当下的结果，一个是我前面的结果，但是前面又跟前面又有关，所以你讲越多字，你讲5个字以后，你第5个字事实上是累积第4个字、第3个字、第2个字、第1个字的经验，就是 H 累积过来的，所以它这里有储存机制，然后再输出来，这样子。那为什么要被喂回来？就是你为了修正这个结果，所以它才再回来修正一次这个输出。所以你在做那个语音输入的话，你讲越多，它就会越正确，就是用这个方式来做，这样子。所以 if you don't care about your output, you just keep going. Like we do the tool life，像我做那个模道测试，你没办法在过去就过去不理它了。那你就只好用 one way 这样 LSTM 去 predict， 一直 predict 结果。But when you do the speech recognition or the speech try to type the word, you need to two-way LSTM in order to correct your previous mistake 这样子。所以这是 LSTM 就是这个架构。那这3个是 gate， 这 gate 没有什么，这 gate 只是让他说你要不要让这个输进来新的东西，要不要输出去？这个 get 只是让它愿不愿意让新的字输进来，要不要让现在的东西输出去？那这个 get 是让它要不要记忆在 memory， 要不要记目前的东西，把它记在里面这样子。on 就是记住，不 on 就不让它记住，让它丢清空。那这个逻辑的话，可以做硬体，也是基本硬体的东西。那这是维度的东西 ，normalize， 记得要 normalize 0到1，输出就尽量 normalize。好，那这个就属于跟时间轴有关的 LSTM， use the speech， the computer can type the word for you， 那就是这种用这个方式来做。希望我用语音的方式讲，你比较容易清楚。那 this is the result we do prediction， 这我做 predict 那个结果，就是刀具，橘色的是我们 predict 的结果，这是真实讯号。那我 predict， 我忘记有 predict 后面三个时间点，还蛮准的，就 predict the life of a tool。So the blue one is the real signal. So we always input the real result, and this original one is predict， 那 predict 用3秒钟就记得 ，predict 还蛮准的，虽然讯号但是大趋势是对的，就 life prediction。那所以我们台湾的那个，我再讲一下，我们台湾不是就是乐山基地嘛？啊，乐山基地不是雷达嘛？那雷达它现在高阶雷达，就是因为我以前是飞弹部的，当1年10个月飞弹部的，那个雷达它可以 predict 飞弹从发射出来，根据它的轨迹，它可以 predict 它落点在哪边这样子，所以一直预测，一直预测。那像我们现在地震啊那些都可以做 prediction。那你要做这些 prediction， 一定要超级电脑来做，就 super computer 来做这样子，所以才办法很快的预测，然后通知你这样子，不然你运算速度太慢的就不行。所以我们会放很多 sensor 在很多地方，这样子去收集大量的资料去做 prediction。所以自从 deep learning 发明以后，整个 prediction 的成果就往上拉一级了。因为 deep learning 的 prediction 是一种外场，以前 vision 只能做大部分做内场 interpolation，prediction kind of extrapolation 外场，它做得很好。tracking 是一种外场。So today we talk about tracking is prediction. Common filter is prediction. LSTM is prediction. RNN is prediction. So prediction 会越来越，我们天气预报会越来越准确这样子。所以我在美国的时候，他们已经要纽约那边已经要做到那个雨量哈，他希望做杜普勒雷达，希望做到什么程度？我雨可以预测到在哪个接口，这条街这边要下雨，这条街没有下雨， 然后云这样，然后 predict 那边，他们也在做这件事情了，听说是成功的。做这个报告呢，predict 那么准，让你等到那云走掉这样子，是很好的。Okay, so that's for today's talk. So we talk about, and next week we'll talk about GAN. Oh, no, sorry. Next week we have break. It's a birthday for our school. 11月11号，11月11号是下礼拜不要来哦，不要上线。我们学校生日，庆祝学校生日放假一天啊，很高兴啊，就这样啊，下礼拜放假，然后再讲 GAN. That's it for today. Thank you.